Welcome back. Today we're going to be working on the Pythagorean Theorem, Day 2. Our content objective is students will be able to use the Pythagorean Theorem to find the missing side of any right triangle. Language objective is students will be able to explain how to find any missing side of a right triangle using the Pythagorean Theorem. And why am I learning this? Well, it's important for real-world problems like finding the distance between home plate and second base on a baseball field. So the difference between today's lesson in comparison to the previous lesson is now we're going to be finding lengths that are not perfect squares. So what are we going to do if the answer is, for example, square root of 51? That's not a perfect square. So we're going to see how we would handle that kind of problem. So quickly, let's go over background knowledge. It's very important for you to understand that Pythagorean theorem only works with right triangles. Okay, and the Pythagorean theorem, of course, is just a squared plus b squared equals c squared. One thing you got to remember is in order to tell if something is a right triangle, you're looking for this right here, which indicates that we have a 90-degree angle. We need to remember that the shortest sides are the legs and the longest side is the hypotenuse, which is always opposite of the right angle. So I always draw a line across to see which one is my hypotenuse. Another thing to understand is A and B are interchangeable since they are just the legs. It really doesn't matter. You only have to be very specific on which you label as your hypotenuse. Okay, so here's a quick example from a previous lesson. What we did first was identify the hypotenuse, identify the legs, plug it into our formula, and proceed to solve, like so. So in this case, we would have said the missing hypotenuse is 10. Okay, so let's go ahead and do the same thing with our first example here. We're going to first find the hypotenuse. So I'm going to go across from the right angle and see that the hypotenuse is b. Therefore, the legs are going to be 4 and 6. So I'm going to plug that into the formula. A squared plus b squared equals c squared. It doesn't matter which one you label a, which one you label b. So I'm just going to call a the 4 and b the 6. So here we have 4 squared plus 6 squared equals the hypotenuse squared, which is b squared, leaving us with 16 plus 36 equals b squared. Simplify 16 plus 36, it's 52. We're almost done. Since we have 52 equals b squared, we're just going to take the square root of both sides and be left with the square root of 52 is b. Here, just like I said earlier, we're going to be dealing with numbers that aren't perfect squares. What should I do? Well, I'm not sure if you remember from a previous lesson, but we have estimated non-perfect square roots to the nearest 10th. That's what we're going to be working on today. So here we're going to go ahead and approximate the square root of 52 to the nearest 10th. So first you always want to decide, okay, the square root of 52 is between what two perfect squares? It's between the perfect square root of 49 and 84. So simply simplify those and say, okay, square root of 49 is 7, square root of 64 is 8. So now I know the answer is between 7 and 8. I like to mark the halfway point and ask myself, okay, is 52 closer to 49 or to 64? Well, let's see. From 49, it's about 3 away. And from 64, it's about 12 away. So I'm definitely going to say it's closer to 7, so I'm going to eliminate these numbers. It's not wrong to check these numbers, but most likely it's going to be a waste of your time. So I do want to test numbers between 7 to 7.5. So since it's so close to 52, why not try 7.1 squared? That's going to be 50.41. That is under, so I'm going to go higher and try 7.2 squared, which is 51.84. And this one is close. It's just a little under. I would say, let's see, it is 0.16 under. But to really confirm whether or not this is the closest number, I'm going to go ahead and try one more. 7.3 squared is 53.29. This is over, so let's see, it is about 1.29 over. So I can guarantee by this point that my answer of square root of 52 is approximately 7.2. Now, I've said in the past, whenever you're rounding to the nearest tenth, you should try one that is over and one that is under and see which one is indeed closer. Sometimes we assume too much and stop too quickly and say, one is the answer, but I really want you to check one that's under and one that's over. So here, to answer the question, the missing hypotenuse is approximately 7.2. Okay, so let's try another one. Here, let's go ahead and find out which one's the hypotenuse. I'm going to say the hypotenuse is B, and then therefore 4 and 2 are the legs. Plug it into your formula, a squared plus b squared equals c squared. We have 4 squared plus 2 squared equals b squared, which is 16 plus 4 equals b squared. 16 plus 4 is 20, so if 20 equals b squared, in order to solve, we're going to take the square root of both sides, leaving us with the square root of 20 equals b. Once again, since the square root of 20 is not a perfect square, we're going to go ahead and estimate to the nearest tenth, because that's what the instructions tell me to do. Okay, so here it says approximate square root 20 to the nearest tenth. Here we got to figure out between what perfect squares the square root of 20 is between. I'm going to say it's between square root of 16 and square root of 25. Square root of 16 is 4, the square root of 25 is 5. So now we need to determine where is it closer to. Is it closer to 4 or is it closer to 5? Well, let's see. 16 and 20 are 4 apart, and 20 and 25 are 5 apart, which means I can go ahead and eliminate this side, okay, any numbers from 4.6 all the way to 5. Now, notice I didn't exclude 4.5 because that is the middle ground, okay? So here's the thing. The numbers are very close, so this is a good time for you to try 4.5. Okay, but if you didn't see that and you decided to do 4.4 instead first, it's okay. So here, let's see, 4.4 squared is 19.36. This is under about 0.64. And then since it's under, let's go one up, 4.5 squared, which is 20.25, which is over 0.25. So here's the thing. I'm thinking a lot of students will check this one first and think, oh, it's really close, and stop. And you would have been right. But again, it's always a good idea to check one that's over and one that's under before you make your conclusion of what you think the answer is. So here I'm going to go ahead and say that the answer to the square root of 20 is approximately 4.5. But to answer the question, I would say the missing hypotenuse is approximately 4.5. Okay, so let's try another one. It says find the missing length and approximate the answer to the nearest tenth. So here, let's find the hypotenuse. I'm going to say it's 7, making 4 and x the legs. Plugging into my formula, a squared plus b squared equals c squared. I'm going to be left with 4 squared plus x squared equals 7 squared. 4 squared is 16, so we have 16 plus x squared equals 7 squared, which is 49. Now this one is slightly different, but we've practiced this before. I'm trying to isolate x. So the first step would probably get rid of the 16. So the inverse of that would be to subtract 16 from both sides, leaving me with x squared equals 33. 33 is not a, backtrack. We're going to take the square root of both sides, leaving me with x equals the square root of 33. Square root of 33 is not a perfect square, so we're going to have to approximate. So let's go do that real quick. Square root of 33 is going to be between the square root of 25 and the square root of 36. So now I'm going to simplify. Okay, so square root of 25 is 5. Square root of 36 is 6, meaning my answer is going to be anywhere between 5 and 6. However, since, let's see, 25 and 33 are 8 apart and 33 and 36 are 3 apart, I'm going to go ahead and eliminate all the choices from 5 all the way to 5.4. Meaning I'm going to try numbers between 5.5 all the way to 6, since 33 is closer to 36. Okay, so here a good number you might try, and answers are going to vary depending on the student. You might think 5.6 is closer or 5.7, etc. So it's totally up to you. Everyone's going to try different numbers. So just keep that in mind. So 5.6 squared is 31.36, which I think is under a little too much. It's about under 1.64. So I'm going to go up 1. 5.7 squared is 32.49, which is still under 0.51. So this one's not going to be a number that I look to. So now since I found 2 that are under, I'm not where I want to be yet. I want to at least find one that's under and one that's over. So let's try 5.8 squared, which is 33.64. This one is over 0.64. So I'm definitely going to go with 5.7 because it is closer. So let's say the final answer I'm going to say is the missing leg is approximately 5.7. Just a quick reminder, I'm using the word approximately because the square root of 33 is not exactly 5.7. So you want to indicate that it's not exact, it's approximately. Okay, last type of this one. So here we're going to find the hypotenuse, which is 8, making t and 7 the legs. Plugging that into the formula, we're going to be left with 49 plus t squared equals 64. Let's get rid of the 49 first, leaving us with t squared equals 15. Then we're going to take the square root of both sides, leaving me with t equals square root of 15. That's not a perfect square, so we're going to have to estimate. Square root of 15 is going to be between square root of 9 and square root of 16. So that's going to be between 3 and 4. I'm going to go ahead and mark the halfway point, which is 3.5. Let's see, 9 and 15 is 6 apart. 15 and 6 is 1 apart. So I'm not going to try any of these numbers. I'm going to go anywhere from 3.5 to 4. But since 15 and 16 are so close, I would assume it's very close to 4. So 3.9 would be a good number to check. 3.9 squared is 15.21, which is over 0.21. But let's try 3.8 since that one is over, and this one is under 0.56. So definitely I'm going to go with 3.9 since it is closer. So to answer the question, I would say the missing leg is approximately 3.9. Okay, now I'm going to give you a type that looks a little bit different. Now, what if one of the sides that are given is a radical? What do? Actually, I know it looks a little intimidating, but this is actually an easier problem than the ones you've been working on, I think. So here, let's go ahead and identify the hypotenuse, which is 7, making n and the square root of 33 the legs. So plugging that into my formula, this is what I end up with. N squared plus the square root of 33 squared equals 7 squared. Now, the reason why I would say this is easier is because when you take the square root of something that's squared, it basically undoes itself since there are inverse operations. So it's just going to leave me with n squared plus 33. There's not a lot of math calculation involved, so that's what's nice. So that's going to equal 49. I'm going to get rid of the 33 by subtracting 33 from both sides, leaving me with n squared equals 16. Now we're going to take the square root of both sides, leaving me with n equals 4. This one worked out nicely since the square root of 16 is a perfect square. So that's it. So notice you don't always have to approximate. If your answer is a nice whole number, you're good. Okay, so here I would say the missing leg is 4. Okay, now moving on to some word problems. It says here, a car drives 9 miles due east and then 12 miles due south. How far is the car from its starting point? So first, we need to understand in which direction was the car moving. They use the words east and south. So for those of you who don't know the directions, I always remembered it as never eat soggy waffles. So here are the directions. If the car was moving 9 miles east, it's going to the right 9 miles. And if it's traveling 12 miles down south, that's going 12 miles down. So it's basically asking us how far is the car from the starting point. This is where they started from. So how far is the car from the starting point? Hopefully you recognize that that's basically just the hypotenuse. And the reason why we're able to call that as the hypotenuse is because when you're moving directly from east to south, you are moving in you're creating a 90-degree angle. So now I'm going to go ahead and plug it into my formula, which is known as the Pythagorean theorem. But first, before I do that, let's identify which one's the hypotenuse. I'm going to call x the hypotenuse and 9 and 12 as the legs. So my formula is a squared plus b squared equals c squared. I'm going to go ahead and replace 9 and 12 for a and b, and then x for the hypotenuse. So we have 9 squared plus 12 squared equals x squared. 9 squared is 81, 12 squared is 144, x squared is, of course, x squared. Now I'm left with 225 equals x squared. So we're going to take the square root of both sides and find that the distance is 15 miles. So to answer the question, I would say the car is 15 miles from the starting point. So notice here, you can use the Pythagorean theorem to calculate distance. So keep that in mind. Notice it's limited because you can only use the Pythagorean theorem when you have right angles. But if you do, you can definitely use it to find distance. Okay, now I would like you to go ahead and pause the video and try number 7 on your own. So for number 4, it says a car travels 5 miles due north and then 9 miles due west. To the nearest tenth of a mile, how far is the car from the starting point? So here, quick reminder of our directions: never eat soggy waffles. If it's traveling 5 miles due north, that's going up 5 miles, and then 9 miles due west, that's going to be 9 to the left. So it's asking us the distance between these 2 points, which basically is the hypotenuse of a right triangle. So because of that reason, we're able to use the Pythagorean theorem. Here we can see that the hypotenuse is x, which makes 9 and 5 the legs. So let's go ahead and plug it in. Here we have 5 squared plus 9 squared equals x squared, leaving us with 25 plus 81 equals x squared, which is 106 equals x squared. Simply take the square root of both sides and we're left with x equals the square root of 106. Since it isn't a perfect square, we're going to have to round to the nearest tenth, like the instructions say here. So let's go ahead and do that. So let's go ahead and round to the nearest tenth. So I'm going to go ahead and say that square root of 6 is between the square root of 100 and the square root of 121. That means it's going to be between 10 and 11. Here's the halfway point, 10 and a half. Let's see where it's closer to. Well, it's 6 apart, and here it's about 15 apart, so I'm definitely going to cancel out anything from 10.6 all the way to 11. So since it's fairly close to 100, let's go ahead and try 10.2 squared, which is 104.04. This one is definitely under. Let's see, how much is it under? 96. And then since it's under, let's try 10.3 squared, which is 106.09. This one's over, but it's only 0 over 0.9. So I'm definitely going to say that the distance is approximately 10.3 miles away from the starting point. Okay, so that's actually going to conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.